Welcome to the deep dive. We know you're curious and short on time, so let's jump right in.
Let's do it.
Today, we're looking at a really fascinating new study. It's about a Denisovan jawbone, found off the coast of Taiwan, believe it or not.
Yeah, it's quite something. For a long time, our picture of Denisovans mostly came from, Siberia and some genetic clues.
Right, the cold places.
Exactly. But this new paper, it's called A Male Denisovan Mandible from Pleistocene Taiwan, really shakes things up.
So our mission today is what? To figure out what this fossil tells us about them.
Pretty much. What it means for where they lived, how adaptable they were. It's a key piece of the puzzle.
Okay, so before this, we had Denisovans pegged as, high-altitude, cold-weather folks. Siberia, Tibet.
And we knew they mixed with Neanderthals and with our own ancestors.
But direct fossil proof in warmer areas, that was missing.
Totally missing. Which is why this Taiwan find is such a big deal.
So unpack that for us. Why is it so significant?
Well, it's the first direct molecular evidence from proteins, placing Denisovans squarely in a warm subtropical setting.
And this jawbone, Penghu 1, it was found in the sea.
In the Penghu Channel, yeah. But here's the thing. Back in the Pleistocene, the Ice Age, sea levels were way lower.
Ah, so it wasn't underwater then?
Nope, it was dry land. Part of the Asian mainland, actually.
Yeah.
So finding a Denisovan there, it just blows that cold-adapted-only idea out of the water, doesn't it?
It really does. Okay, so tell us more about the actual science. What did they do with this jawbone?
Right, so they used a technique called ancient proteomic analysis. It's pretty cutting edge.
Proteomics, so studying proteins.
Exactly. Proteins are like the cell's machinery. They extracted these proteins from the bone and the tooth enamel. It's incredibly delicate work.
I bet. And what did they find?
They managed to retrieve over 4,200 amino acid residues. Those are the building blocks of proteins.
Oh.
And within that data, they found two specific protein variants. Little molecular signatures, you could say.
Signatures unique to Denisovans.
That's what the analysis shows. Unique to them.
So finding their name tag on the molecular level, are these variants common today?
Well, that's interesting too. Generally, no. They're rare in most modern human populations. But they pop up more frequently in populations, particularly in Southeast Asia and Oceania, where we already have genetic evidence of Denisovan ancestry.
Okay, so it fits. It reinforces that connection.
Precisely. Another layer confirming that ancient mixing.
Fascinating stuff. What about the jawbone itself, its shape and size? Does that tell us anything?
Oh, absolutely. Yeah. The mandible itself is quite robust, strong jaw.
Robust, meaning thick, heavy bone.
Yeah, exactly. And it has large molars, big back teeth, with some distinctive features in the roots.
And does this match anything we've seen before?
It does. Interestingly, these features line up pretty well with the Denisovan mandible fragment found way up on the Tibetan plateau.
No way. So even in different climates, they had similar features.
It seems so. It suggests these might be, characteristic traits of the Denisovan lineage, perhaps especially males. The study suggests this was likely a male individual.
So you can picture this, strong-jawed Denisovan guy.
Right. The paper even has this great illustration, kind of imagining this robust male Denisovan walking around under the Pleistocene Taiwan sun, not hiding in a Siberian cave.
That's a powerful image. So, connect the dots for us. What does this mean for the bigger picture of human evolution in that part of the world?
Well, it really underscores the diversity of archaic humans in Eastern Asia back then, before Homo sapiens became the only hominin standing, so to speak.
It wasn't just us and Neanderthals.
Far from it. You had Denisovans, maybe Homo erectus lingering, perhaps others we haven't even found yet. It was a complex landscape of different human relatives.
Okay, so boiling it down, the big aha moment here is...
Denisovans weren't just cold climate specialists. They were adaptable. They lived in warm subtropical environments too. This Taiwan discovery basically redraws their known map.
And gives us hints about their physique, this robust build.
Exactly. It fleshes them out a bit more.
So here's something to chew on then. What other ideas do we have about ancient humans that might be, wrong or incomplete?
That's the million-dollar question, isn't it? This discovery really pushes us to question assumptions, this adaptability we're seeing. What does that say about the potential, the sort of inherent flexibility within the broader human lineage?
Makes you wonder what else is buried, waiting to rewrite the textbooks again.
Always more to find. The story's definitely not finished.
A good reminder to stay curious. Thanks for diving deep into this with me today.
My pleasure.
Keep thinking, keep questioning, and join us next time for another deep dive.